Currently, I'm not in my ordinary position. I'm in a different position due to the coldness. So I'm sharing my screen, and we're going to begin with looking at the centroid of a triangle, and then the triangle inequality theorem, and then inequalities in one triangle. So we'll begin with the centroid. So we must find the coordinates of the centroid of each triangle. The coordinates of the centroid of a triangle are the average, the mean of the x coordinates, comma, the mean of the y coordinates. So in this particular case, the x coordinates are -7, 0, and 0, and the mean of that is -3. And for the y coordinates, well, you have to make sure that it can write first. And there we go. And for the y coordinates, which are 0, 0, and 3, the mean of them is 1.5. And so it's 3, 1.5, or so it appears. In fact, -6 plus 0 plus 0 divided by 3 is -2. There we go. And 0 plus 0 plus 3 is, and then divide that by 3 is 1. So that's the true centroid right there. So first we find the x coordinate. So -5, 0, and 2. Add them together, we get -3. Divide that by 3, we get -1. And then the y coordinates, 0, 0, and 6. Add them together and divide by 3, and that's 2. So -1, 2. And now for the x coordinates. So it's -6, -3, and 0. Add them together, you get 3. Divide that by 3, you get 1. For the y coordinates, it's 0, 6, and 6. Add them together, you get 12. Divide that by 3, you get 4. So it's 1, 4. But hold on now, just a minute. -6 and -3, add them together, you get -9, and divide that by 3, you get 3. -3 rather. So it needs to correspond to our intuition somewhat. It is the centroid after all. So -3, 4, which is there. Here for the x coordinates, that would be -2, add 0, add 5, which is 3, and divide that by 3, which is 1. For the y coordinates, that would be 0, 0, and -6 divided by 3, that's -2. So 1, -2, which is there. In this triangle, the x coordinates are -1, 0, and 6. Add them together, you get 5, and 5 divided by 3 is 5/3. The y coordinates are 4, 0, and 0. Add them and divide by 3, and you get 4/3. So 5/3, which is 1 2/3, which is somewhere about here. 4/3, which is 1 1/3, which is somewhere about here. I will actually partition that unit square into sort of like 9 cells, and there will be 4 inner dots there, and it will be that one right there in the bottom right-hand corner. For this one, the x coordinates are -10, 0, and 1. Add them together, you get -1, divide that by 3, you get -1/3. The y coordinates are 0, 0, and -4. Add them together and divide by 3, you get -4/3. And now to plot. So -1/3, and -1 1/3, and it's approximately there. Next, for this triangle here, the x-coordinates are -2, 1, and 5. Add them together and you get 4. Divide that by 3, 4/3. The y-coordinates are -4, 1, and -4. Add them together, you get -7, and divide by 3, -7/3. So that's 1 1/3 along to the right, and 2 1/3 down. There. And now for the x-coordinates of the centroid of this triangle. So that would be 0, add 2, add 7, which sums to 9, divide by 3, which is 3. And for the y-coordinates, that's 2, 2, and 6. Add them together, you get 10. Actually, you get 10/3 when you divide. So 3 to the right and 3 1/3 up, which is about there. And now we're given the triangle, but we're only given the vertices of the triangle. So the sum of the x-coordinates is -15. Divide that by 3, you get -5. The sum of the y-coordinates is -6. Divide that by 3, you get -2. The sum of the x-coordinates is -9, which divided by 3 is -3. And the sum of the y-coordinates is -12. Divide that by 3, you get -4. Here it will be -1/3 and 1. And here it will be -2/3 and 4/3. And here it will be 7/3 and -7/3. Followed by finally -17/3, -11/3. Two vertices of a triangle are 0, 0, and 9, 0. And the centroid is 6, 1. So we must find the third vertex of the triangle. So as the centroid is 6, as the x-coordinate as the centroid is 6, that means that the x-coordinates all sum to 18. So the x-coordinate of the missing vertex must be 9. And as the y-coordinate of the centroid is 1, that means that the y-coordinates of the vertices sum to 3, which means that the missing y-coordinate of the vertex must be 3. For question number 1, connect the midpoints of each triangle of each side of the triangle to form a smaller triangle within the original triangle, and then find the coordinates of the centroid of the smaller triangle. What happened and why? So we have to find the midpoints of each side. There and there. And this triangle sort of conveniently has the midpoint there. And then we must find the coordinates of the centroid of the inner triangle. So the vertices of this inner triangle, at the bottom we have negative 3, 0. And above that, we have negative 3, 1.5. And to the right of that, we have 0, 1.5. And for the centroid, we add them together and divide by 3, just like before. And of course, the centroid is exactly the same. And the reason why this happens is because each of the x coordinates is the distance between the if we consider the one-dimensional case, then the centroid is clearly just the midpoint, and therefore this is sort of like saying half everything to the right and half everything to the left, and so the middle will remain the same. And now we must check that we can check. So bring that to the left. And bring that outwards. And there's a missing closing bracket there. And it's all correct. So we save and move on to the next job, which is the triangle inequality. Understanding the triangle inequality. State if the three numbers can be measures of the sides of a triangle. So the triangle inequality is violated if the largest number exceeds the sum of the two smaller numbers, because that's impossible. You can't make a triangle out of those. But in this particular case, it's not violated. And so we say yes. In this case, it is. So it can't be a triangle. In this case, it's not. It's not violated, so it can be a triangle. And you may think, wait, this doesn't seem possible, but it's just an isosceles. This is impossible. And that's impossible there. No, it isn't. Beg your pardon. That's perfectly possible. That's absolutely fine. And for this one here, this is absolutely fine as well. Appears to be a sort of error in thinking. So that's fine. That's fine. That's fine. Fine. Good. It makes me suspicious that only one is sort of a problem. But they all seem fine. Nearly all of them seem totally fine. Including this one and this one. So that makes me very suspicious. Perhaps I've misunderstood something about this. No, I was correct. Two sides of a triangle at the following measures. Find the range of possible measures for the third side. So the third side of such a triangle, well, it could range from 4 all the way up to 14. But it can not be those values. It has to be between them, strictly between them. Likewise, this one can range from 3 to 13 by the triangle inequality, and this one from 4 to 16, and this from 3 to 15, and this from 3 to 19, and this from 3 to 25. And we check. And that's all correct, and that's all good. And now we will try looking at inequalities in one triangle. Okay, so perhaps placing it there. Order the angles in each triangle from smallest to largest. Okay, so think of a 3, 4, 5 triangle. 3 on the base, 3 as the base, 4 as the rights, 3 as the base, so position it horizontally in your mind. 4 as the altitude, so position that on the right, and then 5 is the hypotenuse, so just connect the two vertices. Notice that 90 degrees, which is the largest angle, is opposite the largest side. And 53.13 degrees, which is down in the bottom left-hand corner, that's the second largest, and that's opposite the second largest side. The second largest angle is opposite the second largest side. And so all that leaves left is the 36.87-ish degrees, which is up in the top right hand corner, and that's opposite the smallest side. So applying that to just all triangles in general, angle L is largest, and angle K is second largest, and angle J is third largest. Here, angle K is largest, angle M is second largest, and angle L is third largest. In triangle RQP, we have the lengths of the sides. Side RP is opposite to angle Q, which is the largest. Side QP is opposite angle R, and side RQ is opposite angle P. In triangle TUV, side UV is opposite angle T. Side TV is opposite angle U. And side TU is opposite angle V. Now name the largest and smallest angle in each triangle. So we can say the largest is angle C, and the smallest is angle B, and the largest is angle Y, and the smallest is angle X. In triangle UVW, the largest angle is angle U, the smallest angle is angle W, the largest angle in triangle EFG. The largest angle, because this is an isosceles triangle, and in fact it's an obtuse isosceles triangle, the largest angle is angle F. And angle E is congruent to angle G. Now order the sides of each triangle from shortest to longest. So from shortest to longest, so side GE is the shortest. Side F, I do want to sort of do it alphabetical. EG is the shortest side. FG is the second. And GE, who does that leave? Left. That leaves left EF. And next, the shortest side is LM, followed by LN, followed by MN. In the triangle VWX, the shortest side must be VX, followed by WX, followed by VW. In the triangle STU, the shortest side must be TU, TU followed by the side ST, followed by the side SU. Next up, name the longest and shortest side of each triangle involved. So for this, we need to actually find this missing angle here. So 46 at 102 is 148. Take that from 180, that's 32. And so now the shortest side, they've only asked for the longest and shortest. They haven't asked for an ordering. The longest side is AC, side AC, and the shortest side is side BC. Here, the longest side. For that, we must point out that this is an isosceles triangle. It's an acute isosceles triangle, and therefore the sides EF and ED are congruent. And the shortest side is DF. In triangle DEF, the measure of angle D is 35 degrees, the measure of angle F is 95 degrees, and therefore the measure of angle E is 50 degrees. And they are asking us to name the longest and shortest sides in this triangle. So the longest side is opposite the the largest angle, so I feel that I've made a mistake here. No, that's fine. The longest side is the side that is opposite to angle F, which is side DE. And the shortest side is the side which is opposite angle D, which is side EF. The longest side is opposite angle L, which is side KM. And the shortest side is opposite angle M, which is side KL. In triangle ABC, AB is the longest side, 70 degrees is the measure of angle B. Find the range of possible measures for angle A. So this means that AC, oh no it doesn't. Interesting. Oh, the range of possible measures for angle A. Okay, that's absolutely fine. Well, if AB is the longest side, then C must be the largest angle, and so C must exceed 70 degrees. So, for example, let's just say that C is 70 degrees, even though it must exceed it. Well, then that means that A is 40 degrees. So 40 degrees is the hard ceiling to angle A. And as angle C grows larger, angle A grows smaller. So the measure of angle A is bound by 0 and 40 exclusive. In the triangle XYZ, XY is the shortest side and 30 degrees is the measure of angle Y. Find the range of possible measures for angle X. Okay, so XY is the shortest side. 30 degrees is angle Y. the measure of angle y. And so z must be the if xy is the shortest side, then z must be the smallest angle. And we must find the range of possible measures for angle x. So that means that z has a hard ceiling of 30 degrees. And let's just say that it is 30 degrees. Well, then x would be 120 degrees, but as we make it smaller, x becomes bigger. So 120 degrees or high, or just a second now. Okay, so this must be angle z cannot be greater than 30 degrees. If it were 30, then angle x would be 120. And of course, angle z cannot be lower than, cannot be reached 0. But if it was 0, then x would be 150. And so we bound x between 120 and 150, measure angle x like that. And over here we check. AB is the longest side. So C is the largest angle. So C has to be 70 minimum, which means that A is 40 maximum. But okay, so that seems altogether okay. But now we must check everything. Check and understand. Check and understand. So they JKL. So I've done it from largest to smallest, which doesn't actually follow what they said. So that's actually wrong. But the way I can correct it is to say that that's a misread. Okay, LMK, QRP, VUT. Yes, I get it. It was from smallest to largest. Okay, that's correct. So is that. And so is that. Yes, that's all correct. And that's good. And be well, be well.